All right, so in this lesson here, we're going to take a look at reasoning to solve problems, or things are true and false. And to try to take a look at, is something true, is it false, is there a fallacy in the proof, and so on and so forth. So to prove that something is true, that each part of our proof must also be true. Okay, so if you're trying to prove something and you kind of go through and one of the steps doesn't make sense or isn't true, that creates a fallacy, and then it means that the whole thing is not true. So it's actually a proof that doesn't work. So if something doesn't work, the full proof falls apart due to the fallacy. Okay, sometimes the fallacy is hard to find, and even the person who proved it is confused. So here's something that I am going to prove, and I'm going to at least try to prove here, that an area of, or set 65 is equal to 64. Now some of you might be looking at that and saying, Mr. Barkman, you're a little nuts. 65 is definitely not 64. They are two completely different numbers. One is odd, one's even. One's divisible by 5, one's divisible by 8. They're completely different numbers. But if we were to look at this graphic right here and find the area of this rectangle, which is made up by these four shapes, we get an area of 65 square units. We take the same four shapes, rearrange them into a square that has an area of 64 square units. Now, is this a proof, or is there some fallacy that is in there? Okay. I'd like you to take a look at this. Are these all the same size? Okay. Is this triangle same size as this triangle? Well, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. These are both 3 by 8. This triangle and that triangle, both 3 by 8. This piece and this piece here, so slightly twisted around, but have the same size. They are 5 and 3, 5 and 3. And it's 5 wide, 5 wide. This piece here, same as this one. Okay, these are 4 identical pieces. Yet, we know that 65 cannot equal 64, so there must be an error in the proof. Okay? And that is where it becomes a bit of a struggle. Now, what actually happened here is I've doctored these images just a little bit. Okay? While this is 3 up here, so it's a 3 by 8 triangle, okay, which would have an area of 12 square units, this here cannot actually be 2. Okay? So this part right here, okay, is actually not 2. If we want to talk about slope, if you remember from slope of a line, the slope of a line that has a rise of 3 and a run of 8 is different from a slope that has a rise of 2 and a run of 5. So these triangles are in fact not correct. Okay? They are not drawn correctly, and it creates a slightly larger triangle, and these become slightly larger as well, and we get an area of 65. So the fallacy is in the inaccurate drawing. Now maybe you can be happy on this one here that you're not in class, as I usually take about 10 minutes to figure this one out, and we've gone through a little quicker today. But it's important to understand where the fallacy is and to take a look at all the different resources that we have to prove that something is inaccurate or in fact something could be true. Now, 65 equaling 64, definitely not true, but there is something to be said about knowing where that inaccuracy may lie.